Good morning, geometry, or afternoon, or wherever you are taking this. All right, we are going to talk about measuring angles, section 1-4. This is awesome because it's like angles are everywhere. So go ahead and look through this. Which angle below, if any, are the same size as the angles at the right? Describe 2 ways you can verify your answer. So here's their angle they're looking at, and feel free to pull out which ones are the same angle. All right. Essential understandings is you can use number operations to find and compare the measures of angles. Let's take notes on this. Go ahead and write angle is formed by 2 rays with the same endpoint. So you have 2 rays, 1 ray, 2 rays, that's an angle. The rays are the sides of the angle, and the endpoint, or this point right here, is called a vertex of the angle. So you have sides of an angle and you have a vertex. We name angles by saying this one is, its vertex is A, angle A. At point, we also can name it at a point on each ray. So we might say the vertex, or we might say angle BAC, or you can also angle CAB, so it can go either way. Or you might just have a 1 in there and name it angle 1. The sides of an angle include ray AB and ray AC, with the vertex is A. 2 other kind of familiar terms that we need to know are interior and exterior. So you name the angles and they have the 3 points. You need to kind of say which is the inside of the angle. So they contain 2 of the points between the 2 sides. The exterior of the angle is the region containing all of the points outside of the angle, and the interior would be the green. Let's keep going with the problems that we're looking at today. Sorry about that. Naming angles. So we talked about that. There are 2 names for angle 1. You would say JMK, or you could say KMJ. It's also angle 1. So if you're looking at that, remember you can go different directions. So go ahead and try and solve the got it on your page under your notes. And going to postulate 1-7. This is the protractor postulate. So if you consider OB, so look at ray OB, here's the center going out, and a point A on one side of OB, so it's on, a point is out here. Every ray of the form OA can be paired 1 to 1 with a real number from 0 to 180. So what does that mean, or how does that look like? But that's the postulate. It can be paired 1 to 1 with a real number, 0 to 180. So the postulate allows you to find this measure of an angle. Consider the diagram here. So the measure of angle COD is the absolute value of the difference between the real numbers paired with the line OC and the line OD. That is, OC corresponds with C, and OD actually corresponds with D. So that means angle can be COD is actually the difference between C and D. So depending if this is, it looks like it's about a 32-degree angle, and you keep going over, and this is about 135. So the angle would be the difference of those 2 numbers. That would be postulate 1-7. So in looking at angles, we have 4 different types. One's an acute angle, so that usually means it's smaller than 90. Right angle, you've seen that before, that is a 90 degree. Obtuse angle is somewhere between 90 and 180. So it's a bigger angle. It's bigger than 90, but it's not past 180. And then a straight line always equals 180 degrees. We use this symbol in the diagram, and that will indicate a right angle. So when you put a little square in there, the degrees are always 90, and that's how you mark it when you're drawing. Problem 2. What are the measurements of LKN? So look at LKN, and then we want to know what JKL is, and we want to know JKN. And you need to classify each of those. So which ones are acute, which one is a right, and which one is a straight. Go ahead and think through this process, naming and then getting the real numbers, or using your 1-to-1 real numbers from 0 to 180, and you can subtract those to get your answer. So if you have one that's 145 and you subtract 0 from it, that angle will be obtuse because it's 145. Look through these. Go ahead and do problem 2. Stop the video. All right, as we keep going, angles with the same measure are called congruent angles. This means if you have a measurement of angle A equals the measurement of angle B, then angle A is congruent with angle B. You can also say that if angle A is congruent to angle B, then the measure of angle A and the measure of angle B are congruent. You can mark each angle with arcs and call them the same. That means they are congruent. Similar to when we did the line segment, we had 1 mark for that. You can do 1 mark within the angle to specify that those are congruent. Let's keep going. We're going to go problem 3. Look at the synchronized swimmers using congruent angles. Synchronized swimmers form angles with their bodies, and it is shown. So let's look at the diagram. If you have G, H, J, and it is congruent with K, L, M, because they are both 2 arcs, then I can say that G, H, J is equal to K, L, M because they are both 90 degrees. Use the photo and try and figure out what the measurement of ABC would be, equal to 49. So then what is measure DEF? Look at that. Postulate 1.8, angle addition postulate. If you have a point B is in the interior of angle AOC. So here it's saying there's this ray coming out of this angle, and it's in the interior part of it. Then it says that if you use the measure of angle AOB, you can add the measure of BOC, and you will get the angle of AOC. Go ahead and work on problem 4. Using the angle addition postulate, how does that look? If I have an angle addition postulate, and we are calling angle RQT, oops, that goes all the way, RQT is 155. What are the 2 angles? Well, with that, you are basically saying, I want to add this angle, RQS, to TQS, so I can get the whole obtuse angle, ROT. With the angle postulate, I know this equation, ROS, this is the same as my measurement of RQS. So I'm adding that, this is the red, and then the blue, which actually should be over here, is 3x plus 14 equals 155. So I'm just substituting in these equations for the measurement of the angles in this postulate. Figuring that out, we solve for x. We want to combine our x's. We want to combine our integers, and we have 7x. We're doing the 4 plus the 3. And 6, the 20 minus the 14, and that will give us 155. Move your 6 over so you can get your x on one side by itself. 7x is 166, and we come up with x is 23 when we divide by 7. Now, that's one step. Then you need to put it back into your equation, similar to the segments that we did. You know your x, now put x in for 4x minus 20. Calculate it out. 420 times 23 minus 20 is 92 minus 20, or 72. Then see if it works for the measurement of TQS. 3x plus 14, that's we're getting it from here. And you want to put your 23, which we got, for x, into your equation, and then solve, and that gets you 83. Go ahead and do this one on your own. Stop the video. And that looks good. Our assignment for today will be on page 31. Check your Google Classroom.